Okay, so we're going to have a look at nearest neighbour analysis. This is a statistical tool that we use on data to show us the nature of how it's distributed within space. In an exam question on nearest neighbour, there's going to be several different sections, and we're going to go through a worked example later on in this, explain everything. But first we're going to have a wee look at what the data can show us. So here we can see three types of data. You can have clumped, uniform, or random data. And the way we can tell what type of data we have from the calculation is that we'll receive an RN output, and it'll be on a range from 0 to 2.15. Values near 0 represent clustered data, values near 1 represent random data, and values near 2.15 represent regularly distributed data, which is usually in the form of a sort of pattern. So what we're going to do now is we're going to have a look at a past paper example from January 2013 on AS2. So if we zoom out, the question is essentially about the distribution of airports in Texas, as we can see on this diagram here, on this figure, resource A. Another important thing to look at in this question is the hypothesis, and we'll come to that later on. So it reads, airports within Texas exhibit a significantly regular distribution pattern throughout the state. Okay, so the first part of this exam question is actually really easy. And if we look at it here, what you have to do is fill in the table on this page, and you have to find the nearest neighbour for airport number 3, airport number 7, and airport number 18. And this is really simple. All you have to do is look at the map and find the airport, so the dot, that's located closest to number 3, 7, and 18. And I've done that, so the nearest neighbour for number 3 is airport number 4, for number 7 it's number 6, and for number 18 it's number 19. And this is really just a matter of having a look at the map. We even have a scale here, so I would use a ruler and measure this distance. If you're unsure, perhaps maybe between the distance between 7 and 8 and 6 and 7. And all you'll do is measure the distance to find the nearest neighbour. Okay, so now we'll actually move on to the calculation. Alright, now in your exam you'll be supplied with a resource sheet or a formula sheet. Here is your nearest neighbour formula. Now you don't actually need to know this, so you're shown what each of the variables mean here, okay? So D is the mean distance between the nearest neighbours, okay, and remember it's the mean, so we'll come to that in a wee second. N is the number of points total, so the number of airports in our case, and then A is the area, the size of the area in question. And then once we have our results, once we have our RN result from performing our formula, which we'll do in a minute, what you'll do is you'll take your value and you'll refer to this figure, okay? So you'll read across for your number of points and then go up the y-axis according to your RN value, and we'll do that in a minute with our worked example. Okay, so to our actual example, to get the data that we need to fill in our formula, what's really important to point out is we're actually given the total land area of Texas here. Okay, so we'll use that value in a minute. And in order to calculate the mean, what we're going to do is we're going to take this value, which is the sum of these two columns, the total distance between the points. We're going to take this value, and what we're going to do is we're going to divide it by 62 in order to get the mean, okay? So there's 62 airports. We're going to divide the sum of the total distance between the nearest neighbours by the total number of airports, and that's going to give us a value of 77.28, okay? Now, onto our calculation. If we have a look at our question sheet, I've already put our formula up here. Remember, that'll be on your formula sheet. So if we use the values that we have, we've already calculated the mean to get our 2D, so we'll do 2 times the mean, which is 77.28, which gives us a value of 154.55. We're then going to multiply that value by the square root of 62, which remember was our total number of sites, over the area of Texas, which was that big number, and we can even find it here, land area of 691,030 kilometers, and that gives us a value of 1.46. Okay, so what does that 1.46 value mean? In order to find that out, we have to look up back to our formula sheet, read across. So we have our Rn value, which is on the y-axis. Remember, we were 1.46, which will be approximately here. and we'll read across on the x-axis to the number of points that we had. Remember, there were 62 airports in Texas. So if we go from 62 up to where 1.46 would be on the graph, approximately here, and we look, we're in the significantly regular section of this chart. Then, if we refer back to our hypothesis, which was talking about whether or not there was a significantly regular distribution pattern of airports, we can go back and answer the next question, which is comment on the relation of the hypothesis, and we can say that the hypothesis was accepted. Now, there are two really important things to emphasize when we're doing a nearest neighbour question, and it's all to do with common errors people make when they're doing the formula. Two things I want to emphasize is remember that we're using the mean of the total distance between. What happens is a lot of people forget that we're using the mean value and will just use the sum, so the total sum, and they'll forget to divide that number by the total number of points. And remember, that's what we did down here. So a lot of people will use this value and forget to divide it by the total number of points, or in our case, the total number of airports. Another thing that people will forget to do is just be really silly, and they'll not pay attention, and they will forget to multiply that mean by 2. Alright? Those are the two common tripping points. Other than that, that is how you perform a nearest neighbour analysis question on your AS2 paper.